This class will see about Lagrange's mean value theorem. It's called, in general, it's called a mean value theorem. What are the conditions? Fx should be continuous in AB and derivable in open interval AB. Then there exists at least one point C in that domain AB such that f dash c equal to f of b minus f of a by b minus a. Now we know that. What is f dash c? F dash c is nothing but slope of the tangent at the point x equal to c. And f of b minus f of a is the average value, that is a slope of the secant over the interval AB. If you look into the figure, this is the tangent line and this is the secant line, right? Two slopes are equal, they're parallel, right? So tangent line will be parallel to the secant line. So if f of b is continuous in AB and derivable in AB, then there exists at least one point C in AB such that f of b minus f of a by b minus a equal to f dash c is what the mean value theorem says. Right? Look, this is my y equal to f of x. AB is the line joining the endpoints of the chord AB. Slope of that chord is f of b minus f of a by b minus a. That is the tangent parallel to the chord. And slope of the tangent is f dash c. Right? At least one point, I mean there can be more than one point, where the slope of the tangent equal to slope of the line joining the endpoints. Just go through the points there. Here there are 4 points, namely C1, C2, C3, C4, where the tangent is parallel to the chord joining the endpoints. Let's do some examples over here. Consider the following function, f of x equal to x cubed minus 12x in the interval minus 2 to 2. Let us first establish the necessities. What does the mean value theorem says? It says that there exists a number c such that f dash c equal to f of b minus f of a by b minus a. Now what is f dash c? It's f of 2 minus f of minus 2 by 2 minus of minus 2, and finally if you simplify it's equal to minus 8. And we see that f dash x equal to 3x square minus 12. So f dash c equal to 3c square minus 12. By mean value theorem, that equal to minus 8, which implies c square equal to 4 by 3. C equal to plus or minus root over 3, that equal to plus or minus 1.155. Okay. Consider another example. f of x equal to 1 by x on the interval minus 2 to 2. Mean value theorem suggests that there exists a c such that f dash c equal to f of b minus f of a by b minus a. Now we see that there is no value of c that satisfies the equation. Think why? Because f of x is not continuous in the interval minus 2 to 2, because x equal to 0 belongs to that interval. Take another example. Determine if the mean value theorem applies, and if so, find the value of c, where f of x equal to x plus 1 by x on 1 by 2 to 2. We see that f is continuous in 1 by 2 to 2, and also we see that f is differentiable in that interval 1 by 2 to 2. By mean value theorem, f of b minus f of a by b minus a equal to f of 2 minus f of half by 2 minus half, and that in turn equal to 3 by 2 minus 3 by 3 by 2, and that in turn equal to minus 1. They should be equal to f dash x at the point x equal to c. Now what is f dash x? By u by v rule, it's x into 1 minus x plus 1 into 1 by x square, and that equal to minus 1 by x square. Okay, now equate both the things. You see that minus 1 by x square equal to minus 1, which implies x square equal to 1, which implies x equal to plus or minus 1, but minus 1 doesn't belong to our domain here. Here it is a half and a half, and so x equal to plus 1, so c equal to 1. You just go through the another example here. F of x equal to x power 2 by 3 on minus 1, 2. It's continuous being a polynomial. F dash x equal to 2 by 3 x power minus 1 by 3. That's 2 by 3 into x power 1 by 3. And f of x, we see that it's not derivable at x equal to 0, and x equal to 0 belongs to our domain, so mean value theorem is not applicable here. Why? It should be derivable in the interval minus 1 to 2, but f dash x equal to 2 by 3 x by 2 by 3 into x power 1 by 3, which is not defined at x equal to 3, which is not defined at x equal to 0. And x equal to 0 belongs to our domain. And it should be continuous and it should be derivable at all points in the interval minus 1 to 2, right? It should be continuous in the closed interval minus 1 to 2, and it should be derivable at all points of x in the interval minus 1 to 2. Okay, right. You understand this problem, try to do it yourself. Model that to the mean value theorem. Keep in mind that your function should be continuous, it should be derivable, and f dash c equal to f of b minus f of a by b minus a. Yes, do it yourself. Okay, this is the alternate form of mean value theorem. So we can also rearrange it as f of b equal to f of a plus b minus a into f dash c. This leads to the Taylor's theorem. So we'll see the Taylor's theorem in the next class.